Okay, so we've done this, and as the book points out, this is really arguably the most common method of organizing. Although for small startups in the beginning, these divisions may not be so clear. But as the company grows, hopefully they will become clearer and clearer, and so it will become easy now for the organization to be able to say, well, who was supposed to have done this? Was it finance or was it production? Okay, and one of the units that we need to think about when we're talking about information systems, of course, we are talking about IT, and so the IT function becomes important. And how is it organized? Well, in this case, for lack of space, the diagram only shows 4 functions. Of course, there'll be more that way. There'll be accounting, there'll be HR, and there'll be manufacturing and all that. But if you focus exclusively on the IT function, here they call it the computer services unit or department. Some people may call it the information systems department. The names will vary depending on the organization. And typically, you will have these roles within that unit. Systems development, these will be the guys that are designing, for instance, new systems. When we say we want to implement an account information system, then it may be that you are developing it in-house, and so the guys within this unit will be doing the analysis, the design, and the coding. Naturally, of course, they will not be alone. Your users must be involved, so your accountants must be involved because they are domain experts. They understand accounting presumably more than the IT guys. And so if you leave it entirely to the IT guys, then it is unlikely that your system will meet your requirements. In fact, it's more likely that the system ultimately will fail. Systems that are useful have some lifespan and they need to be maintained. Maintenance may mean that you are correcting, so it's called corrective maintenance, some aspect of the system, or it could be that you are enhancing some aspect of the system. Or sometimes it may be that the system was designed to run on some operating system, and perhaps that operating system or that version is no longer being supported. And here, notice again the ambiguity that you need to resolve from the context, the ambiguity of the word system. That you have a system, an accounting system that is running on some operating system. And that operating system is installed on some computer system. So there are different levels here when we use the same word system. And with information systems, the idea of a database is always critical. Remember, your system is taking in data that it's going to process to produce information. So you need ways of managing that data. So you need a function that is concerned with database administration. And of course, you're processing data, so you need a function that focuses on that. The nomenclature will not always be the same. Some organizations will maybe somewhat faithfully be following this, but others will be using entirely different terminology. Things like data control and data library may not be so fashionable anymore. The key determinant, of course, will always be the needs of the particular organization. Now, when thinking about processing data, people often distinguish between distributed processing and centralized processing. And there's of course, the there's nothing that says you have to go with distributed data processing only, or you have to go with centralized database processing only. You could mix and mix the two, and mix aspects of the two and fall somewhere in between. But I think to understand the distinction, let's look at this diagram that comes from a popular database book. If we look, let's start with the diagram on the right. In this case, there's a single database. That's all the sites are accessing. So in terms of the database is centralized. But this site can in fact request for data from the database. The data will be shipped to the site, and the site can do whatever processing it wants to do on the data. Excuse me. So a simple example may be that perhaps we are a university with campuses in different cities. Our database sits at some central location. So campus 1, somebody here wants to calculate the GPA of some students. And so they write a query that will request for data from the database. The query goes to site 2, and there's a server here that runs the server. Now I'm talking about the software. Again, there'll be that confusion. When I say server, am I talking about a piece of software? Am I talking about a piece of hardware? So the context should always tell you. In this case, you have a database server, maybe something like Microsoft SQL Server, running on a server that is a piece of hardware. So in this case, really, I'm interested in the software idea of a server. So the sites, this campus then writes a query that requests from this server some data. The server turns around and retrieves the data from the database and sends it back to the campus. And the campus does the calculations here locally. So in that case, although the data is centralized, the processing is distributed. Each of the sites can actually do their own computations. You could take it to one extreme, or where you say, well, these guys don't have any processing power. So when a site here wants some GPA, some students' GPA to be computed, it says to the central site, please give me the GPA of this student. And so the request comes in, but the GPA computation is carried out here, and the thing that is sent back is the result. So all the processing happens here. So in that case, if none of these guys has any processing power and all the processing happens here, it means that the database is centralized and the processing also is centralized. This is the kind of thing that people used to deal with mainframes, where the terminals would be said to be dumb, as in stupid, in the sense that they don't have any intelligence, any computing power. They cannot do any processing. So effectively, a terminal sitting here is just a keyboard and the screen. Every time we type in a command, the command is sent to the intelligence where it is processed, and the result comes back and is displayed on the screen. Nowadays, of course, with the cost of laptops and desktops going down all the time, chances are you will have some processing power here. So the processing will be distributed, even if the database is centralized. This diagram on the left says the database is distributed. So if we stay with our example of a university with different campuses, then it would mean that the Franciscan campus maintains this database, the Mount campus its main database, and the Habron campus its own database. So when a student says in the Mount campus says, my GPA, the data is here, the computation is done here. But because the system is interconnected, this guy can still ask for data from this guy. And this guy can still ask this guy to do some computations for him. So in this case, the database is distributed and the processing is distributed. So the organization will decide, looking at its own requirements, but also you need to think about things like the reliability of your networks. If your communication channels are not reliable, then it would mean that frequently when the Maun guy says, can I have data, the network perhaps is down and therefore they are disconnected and they are not able to do anything. So in that case, you may want to think about this kind of arrangement. But of course, that also will have its own disbenefits. For instance, in this case, it means that the cost is going up because now you need to think about how you manage data at all the sites. And you're thinking about the hardware, you're thinking about the software, but you're also thinking about the skills, the data administrators that need to look after those systems. So those are things that the organization will need to think about. This picture comes from our textbook, our preferred textbook, our prescribed textbook. And in this case, you are thinking about, say, 3 different campuses of one organization, and they are connected by network channels, and each keeps its own copy of the data it uses locally. But because they are connected, this guy, for instance, is still able to read data from that guy. And if the connection here is dead, or if you look at this, if the connection is dead, this one, if the connection is dead, this guy is still able to do things locally. Okay, I think we have said enough about this, that idea, but maybe before we leave it, let's not ignore the impacts of the web on how systems may be arranged. This picture, I was going to check this, I forgot. I believe comes from this book, but it's something that one would need to confirm. But it now talks about this idea that, in fact, you can even spread your applications across different machines. So simplistically, if we look at the web, this machine and this machine, that would be a typical arrangement where you are dealing with static web pages, where a user clicks on some link on the web browser, and the web browser then sends a request across the network to the web server running on this machine to say, can you give me this particular file? This, because web pages ultimately would be files on your hard drive, just an HTML document. So the web server will then retrieve that file, excuse me, from the hard drive and send it back to the client, and the client displays it on the screen. People will say the web browser will render the HTML document. The document has code that says this should be bold, this should be underlined, and the web browser understands that and is able to display the page the way it's supposed to be displayed. But think about, again, your favorite online retailer. They can't always be only dealing with static web pages. That means it doesn't change. You create a web page, you save it, and it is always like that. Sometimes a user is asking for a price, and prices change. So in that case, it may be that you have data in some database running on some server somewhere, and so when the request comes in for the price of a book, the web server will realize that, okay, I cannot deal with this on my own. So it turns around and talks to the application server The application server realizes, oh, I need help, so it talks to the database server. So the data comes in from the server and ultimately is used to build the web page that goes back to the client. The role of the application server may be quite complicated actually. Imagine, for instance, even if we keep it simple and stay with that example of your GPA, the student says, I want my GPA. So they click they type in the ID and they click on a link. So the browser sends a request to the web server, and the web server realizes that I can't do that computation. I need the assistance of the application server. So the application server here is able to do that computation, but it does not have the data. So it says, oh, I need the assistance of the data server. So it says to the data server, give me the data. The data is shipped to the application server, which does all the computations and then sends the result to the web server. The web server takes that result and uses it to build a web page. So it inserts that into some HTML document. So now you have a complete web page that goes back to the browser. The browser is happy. It asked for a web page. It got a web page. It doesn't know, it doesn't care that behind the scenes there was a lot of running around and data crunching and all of that. It doesn't care. And sometimes the application server may need the services of a more specialized application server. Perhaps here you have a server that runs the more complicated computations. Maybe you are running simulation models. Again, the browser and the client don't really care. Or sometimes you need data from a warehouse. This guy never cares. All they see is the server that is providing service to them. What happens behind the scenes is invisible from the point of view of the browser and the end user that is being serviced. And you can, in fact, if you need to, have many different machines at this layer performing this particular service. So the way you arrange your architecture will depend on your requirements. You have a lot of flexibility, and you can grow your system gradually as your requirements grow. And nowadays, of course, we talk a lot about storing stuff in the cloud. We take pictures with our cell phones, and we will say, oh, they are in the cloud. Whether it is this cloud or that cloud, nobody knows. Excuse me. But the key thing to remember is that whenever you are saving stuff, it means that ultimately there must be some hard drive, some disk somewhere where these things are being saved. And by saying that I'm storing in the cloud, effectively what we are saying is that I don't really want to bother myself with all those details. In other words, there are things that I'm outsourcing. When I say save, what happens afterwards is not my responsibility. I'm outsourcing that responsibility to somebody else. And that somebody else will worry about what machine, what drive, how big the hard drive, how fast the hard drive, how big the machine, what processor. They will worry about what antivirus. They will worry about all of that on their own, including even the skills that you need to maintain and run those systems, and how frequently you need to update and upgrade and all of that. So we are outsourcing all of that, and then it means that also we trust. We trust that whenever we want our pictures, we will get them. We trust that our pictures will be protected. We're not going to see our nude pictures floating around on the web. Or sometimes we are talking about credit card details. They are not going to be floating around, people traveling our money. So there's a lot there that one needs to think about. But a lot of organizations are going that way as well. For instance, a small university that may decide to do that. That rather than when a student says, what is my GPA? And perhaps all of that is on the cloud. In other words, somebody somewhere, maybe in Japan or China, is responsible for that. We give the students the ability to connect to that site, perhaps through a simple web page. So those are things that you want to think about. But rather than buy the software or any of that, you access it as a service. When you want it, you pay and use it and disconnect. Anyway, let's not stay on that. It's not the course is not about that per se. Those are things that we need to keep in mind. The accounting function, of course, is important. You cannot understand, excuse me, accounting information systems if you don't understand the accounting function, because the whole idea is that you are building systems that will support this accounting function. Perhaps most of you are accounting students, and so I'm going to assume that you understand that much more than I do. For those of you that are not, well, actually, you should all have some, because accounting, the first year accounting course is a prerequisite, so I think we can assume that yes, in fact, you do have some basic accounting training. But the accounting function, remember earlier we were talking about it as an information system, so that the whole accounting information system captures and records, transactions that are financial, and they think about their effects, and transactions may include the movement of raw materials from one unit to another, or the shipment of finished products, and blah blah blah. So the accounting function will worry about all of that information, capture it, capture the data, process information, and also distribute that information to key personnel across the organization. And in dealing with information, it is important, of course, that we think about reliability. Can we really rely on the information? And for us to be able to say yes, firstly, the data must be reliable, it must be accurate, but the processing also must be correct. Otherwise, there's no reliability. But the other thing is this idea of independence. Accounting must be independent. They must not be doing things under duress, and so their activities must be separate and independent of the functional areas that maintain custody of the physical resources. That separation of responsibilities will go a long way towards ensuring that the information that accounting produces is in fact reliable. So this slide talks about the importance of that independence. Okay, moving on. But we keep talking about accountants, but of course there are different kinds of accountants. There are different roles and responsibilities. And so when you are designing an accounting information system and looking at accountants, they may be involved as system users, capturing the transactions and analyzing the data. They may be involved as designers, or they may be involved as auditors. And so all of those roles are important. I will not spend much time here. I think these are things that should not be too difficult to follow. But as designers, their domain expertise in particular is important. If you rely entirely on your IT guys to design systems for you, they may not have a sufficient understanding of what you do as accountants for them to be able to design and implement the kind of system that truly meets your requirements. Especially when you think about the kind of legal requirements that you may be required to adhere to. So designing systems will be a joint effort between your accountants and your computer professionals. It can never be computer professionals on their own. the accountants must always be involved. Of course, the accountants also do auditing. You can think about the general, financial audit, but they would also be auditing your system. Auditing, is about instilling confidence in the things that we do, the information that we produce, the reports that we produce, the statements that we produce. So system auditors will need, of course, to understand accounting. I mean, they're auditors, but they also need to understand systems. So some of you may ultimately want to go into roles like that, and also things like fraud audits, where ultimately somebody may be sued, maybe yourself, or maybe some employee may be fired, or all of that, where the auditor perhaps has been asked to come in because there are anomalies that may suggest fraud. And yes, auditors may be internal or they may be external. People talk about the big, I don't know whether nowadays it's big four, but there are also other, auditing firms. So these are external auditors. They represent third-party outsiders. Your people may be thinking about investing in your company, maybe buying shares. So they need some sort of assurance that can only come from external auditors as opposed to information that comes from within. But also internally, management will want things to be checked. Are things being done according to regulations? Is there some kind? So there will be internal auditors that represent management. So the external auditors represent third-party outsiders, and the internal auditors represent management. And when you are thinking about acquiring information systems, there are many ways you could do it. You could develop the system entirely in-house. And people will say, yeah, if you do it that way, then we are more likely to meet your requirements closely, perhaps even perfectly. But also you could buy the system off the shelf. Just go and buy an accounting package, for instance, that other people are already using. Or you could combine, to some extent, the two approaches. Each approach has its benefits. When you develop entirely, yes, perhaps you may be able to meet your requirements, but think also about the challenges. You may get the system completely wrong, or even if you get it right, it may mean that now you depend so much on your internal IT staff. Nobody out there knows how your system works. So when your IT staff members say, oh, we are leaving if you don't pay us this way, and then you worry about who else can come in and maintain the system. If you bought a system that other people are using, then the skills are available in the market. If somebody in town says, I'm leaving, you can just go out there and get somebody to come in. But also when you're in trouble, there are other people that you can talk to. Also, when you are building a system entirely, you are talking about complex systems, and the costs will be high in terms of the kind of things that you need to acquire, the skills that you need to acquire, but also in terms of the amount of time that we're going to build in this system. You may take 4 or 5 years building it, and then at the end realize that actually it does not meet your requirements. So you may want to think carefully before you go that route. Think about buying something that other people are using. Usually your requirements are not going to be so special that they are so different from the requirements of other similar companies. So go to the market and see if you can buy something on the shelf. If you were you were thinking about buying a car, typically your first thought wouldn't be, I must design and implement it. you go to a car dealership and you buy the sort of car that will meet your requirements. So you may want to take that approach when you are thinking about buying off-the-shelf software. Also, off-the-shelf software sometimes will be capturing the best practices within your industry. So by buying it, you ultimately get the benefits of now being at par with the best within your industry in terms of the kind of processes that you need to go through. That might mean, of course, that you are forced to change your processes, but perhaps in doing so, you are gaining, you are changing them for the better. But of course, there are these benefits. It may be that the system does not really meet your requirement. You paid handsomely for the system, but it was not designed with you in mind, and therefore perhaps it does not meet your requirements. So you will need to spend a lot of time evaluating systems. And that means that you begin by documenting your requirements. And once you have that document, then you can check whether the systems you have in mind will in fact meet your requirements. Okay, let's not spend more time on this. This is not a course on acquiring systems, but think about it and think about whether you want a turnkey system that is completely finished. You simply it's like the car, you go inside, you turn the key and you run, or the car runs, whatever the case might be. Or you buy systems where the basic structure is there and you're going to build your own modules around it. Or you buy a system that the vendor will support perhaps entirely. These are complex questions that should never ever be left only to your IT guys. There's a lot at stake. Whether you're thinking about the amount of money that we are talking about here, or the kind of functionality, the kind of benefits and benefits, the risks and gains. So you need your user departments, your accountants and your auditors, and to be involved. And you as accountants, you want to be knowledgeable. You don't want to be fooled by, whether deliberately or not, by your IT professionals. Okay, and of course, talking about auditors, there will not typically be some audit committee, especially when you're talking about the bigger organizations that have a board of directors. So there will be an audit committee, which in fact is a subcommittee of the board of directors. So it reports to the board of directors. We will talk about SOX in, I believe, chapter 3. So let's maybe leave it until then. And that brings us then to the end of this chapter. And let me close it again with a reminder. Let's respect copyright. Let us not circulate. And here is a list of some of the books that I mentioned during this presentation that you may want to look at. This is the book that we are following, but this is also another very good book. And in terms of information systems, management information systems, by the way, and you will have to get used to this that usually, given where I'm coming from, when I say information system, I'm talking about management information systems. But just I will try to update my programming, but my programming is old and a bit fixed, so I may not be able to break all of those connections. But anyway, in terms of management information systems, particularly for say MBA kind courses, these two books are good, and this is a good database book. Okay, let us leave it here, and we'll see you again. And I'm using "see" there in quotation marks. We'll see you again when we do chapter 2. Thank you.